Hello everybody, welcome to Lab Automation Best Practices. My name is Scott Strohmeyer. I am a VMware vCloud and Lab Manager Specialist for the Western US. I am also a former customer of VMware's. I ran a very large Lab Manager environment for BEA Systems before I came to VMware just after the Oracle acquisition of BEA Systems. So I have a lot of personal experience working with Lab Automation and Lab Manager. For those of you who didn't read the description all the way, I should let you know this is going to be mostly focusing on Lab Manager and what we can do in terms of best practices and working in automation with Lab Manager. So I appreciate all of you coming over here during lunchtime. I know it's they've been a little strict on time. And speaking of being strict on time, I'm going to get moving right away because we are relatively short on time and I want to make sure that I get as many questions answered as I possibly can. So first we've got to start off with the legal disclaimer. This talks about a lot of futures and product futures and features and that sort of thing. We don't have to worry about too much of that. Won't be talking a lot about what's happening in the future here. We'll be talking more about best practices and things like that. The first thing I'm going to talk about, and I'm going to touch on this just a little bit, is Lab Manager use cases. So for those of you who haven't used Lab Manager before, most of the use cases that we see with Lab Manager sort of center around lab automation, creating labs for users, developers, testers, QA people, that sort of thing. We also see it frequently used for training, deploying labs for classes, being able to very quickly build up and tear down labs for training. And of course, they use it for us, the sales engineers at VMware, where we have our own virtualized ESX environment that lives inside Lab Manager. Yes, you heard me correctly. As of version, I believe it's 4.0.1, they very quietly snuck in a little feature that allows you to, and I must stress that it's unsupported, but it allows you to install ESXi as a virtual machine inside Lab Manager. So for those of you who have been wanting to do that, you can do that. Just don't expect support from VMware when you do it. But it's a very cool feature, and it's something that we use internally at VMware to give people like myself the ability to spawn up labs very quickly that are clean greenfield labs and demonstrate them to the customers or train ourselves or any of the things that we need to do with them. The other thing that is worth pointing out is that all of the labs that we have spawned here at VMworld's Hands-On Labs have all been driven by Lab Manager. Lab Manager is the core piece of software, and we have a wrapper that's written around its APIs that allow us to spawn these dozens and dozens of labs that we have available for you. And I checked, what was it, middle of the day yesterday, we'd already spawned 6,000 labs and had gotten way past the 50,000 virtual machine mark. And we're hoping to touch 180,000 or 200,000 virtual machine spawns for this 4-day period by the time everything is over with. So Lab Manager is an extraordinarily powerful product. I'm a huge fan. It's one of the reasons why I work at VMware. And it is definitely not without its trials and pitfalls. So those are the things that I'm going to focus on today, and hopefully this will be of help to the folks in the room here. So from a test dev perspective, one of the most important things that Lab Manager can provide is a clean environment. One of the things that I remember working as a release engineer would frequently get bugs kicked back to me by QA engineers telling me that they couldn't reproduce a bug or that they would reproduce a different type of error. And frequently, not always, but frequently it was a problem with their environment. They were going in there, building their machines using ghost images or whatever else they could scrounge together. And rather than spend all the time it took to reimage the machine and do it properly, they just go in there and clean out the virtual machine or the physical machine. And they would say, okay, well, I'm just going to, sweep under the rug and get rid of all these little pieces. And inevitably, there was something that was left behind that broke what we were doing. There would be some kind of error that happened, something would break, and we would spend a lot of time messing around trying to fix whatever problem it was. That was one of my favorite use cases, but as time went on, we realized that we were also able to automate against Lab Manager's API and do things like spawning up hundreds and thousands of test machines that we could use for automated test matrices. We could capture every scenario that we would want to run a piece of software through. We could have a complete battery of tests where it was all captured in the library, and then automatedly we could spawn different tests that would happen where the virtual machines would come out, they would grab the software, they would install it or build it, they would get it installed, and then we would run it through a set of tests that would be necessary to validate whatever changes the programmer had made. So it has a substantial amount of power, but unlocking that power can be a little tough, especially for those of you who are getting used to working with Lab Manager. So the first thing I'm going to talk about is configuring the organizations and workspaces, and this can be more important than you might think. The organizations and workspaces allow an installation to be subdivided into many different parts, and I'm not just talking about siloing the users from each other, I'm also talking about separating out the equipment that you use to give to those users. And one of the first things that a lot of Lab Manager users will learn about is storage. Storage can be a big thing with Lab Manager, and I'll get into that more a little bit later, but suffice it to say, it's very easy to hammer storage in Lab Manager. So one of the things that's worth keeping in mind is if you have multiple groups, it's a good idea to bunker those users, put them on different LUNs, and if you can, put them on different RAID groups on the storage array so that their screw-up doesn't end up affecting your other teams. Same's true with your ESX resources, although that part is much easier to handle. Most of you in the room probably already know how to deal with that. Dividing up different load profiles amongst different resource pools. Not a very big thing, not too hard, but it's worth knowing about. The other thing that you can do with the workspaces and organizations here is you can have different types of workspaces with different types of permissions. If you have certain levels that you need to take software through, for example, if you're developing something that's going to be used internally, you can step it from place to place to place. You can start out with development, you can run it through test, you can put it in a user acceptance test container, and you can have different permissions for different users at different times when they're working with the software and move those configurations between those workspaces. That, for those of you who remember Stage Manager, was the concept of integrating Stage Manager with Lab Manager. Essentially, the stages were merged and they became the multiple workspace function that had the permissions and the bindings to different resource pools. The typical roles I won't get into. This is a bit of an eye chart, but this is available to anybody who downloads it off the VMworld website. The thing that I think is most important about the roles and rights function is that you can mess with and change and copy the different roles and rights and map them to different users in LDAP or Active Directory. And this is very useful in situations where you have specific functions that you either want to enable or disable for specific users. And this is something where it can be very helpful to keep people from doing dumb things like consolidating all their virtual machines because they think it'll help it, stop being slow or whatever it is that they're trying to do. Stuff that they might not have any idea might have an impact on the system, but could end up causing a significant slowdown. So you can go in there and very granularly change what they're allowed to do. In architecting Lab Manager, probably one of the most common questions I get is, what can I do with remote users? You can definitely use VPN connectivity to an installation. You need to be, if you are the user, you need to be able to route to the specific ESX server that the virtual machine lives on, because the console comes from the VM kernel driver on that particular ESX server. So each server in that cluster needs to be able to route to the user in order for the remote MKS plugin to be able to hit that virtual machine on that ESX host. Other than that, you're okay with that. There's no problems in doing this over a long distance. If you get to extreme long distances, like getting from the United States to Europe or Russia or India, one of the things that you start noticing is that faster than light problem that happens when you have a VNC style connection to a virtual machine going over a long link. If you've got about 200 milliseconds or higher latency between you and the virtual machines, the performance is going to be very slow and choppy. And this is something that can be solved by using remote desktop on the virtual machines. Now, the nice thing about the virtual machines here is that even if you're not going to be using a Windows virtual machine, you can just tack on a Windows virtual machine and RDP into it if you're a user. This is something that my old users at BEA would do frequently. Our Bangalore test group would RDP into the virtual machines. They would be able to connect to their sessions, and they would get local-like performance out of the virtual machines that they were working with, because RDP accelerates it so substantially. One of the other things that you can do, and that's something that we do at VMware, is you can use VMware View to connect to your local Lab Manager session, and that will help accelerate the performance of the virtual machines in Lab Manager when you're connecting to them from a long way away. PC over IP can help with that substantially. If you have ESX hosts that are managed by a Lab Manager that is remote, you must keep in mind that they have to be routable, and there can be no network address translation between the networks. And again, the WAN latency is going to be something that you experiment with, mostly if you're in the continental US. performance will be fine. But again, if you're going overseas, you'll have some significant changes in performance. Managing growth in Lab Manager is another big one. I'm going to start out with sizing and scaling here. ESX sizing of virtual machines is the same as traditional ESX sizing. Depends on the workload. Whatever you're doing, if it's web servers, if it's database development, whatever it might be, just size it the way you would normally size it. There's nothing different about Lab Manager virtual machines. Where it is different is in data store sizing. Initially, you have virtual machines that are going to be thick clones. Those thick clones are going to be the base for all of the virtual machines you create inside Lab Manager. Now, the thing that's worth keeping in mind here is you need to understand what your users are going to do with these virtual machines. One of the first things that I did that was a mistake on my part when I set this up as a beta in my old company was I thought that I would be able to throw this at the users and they would figure that out and they would be happy about it. They were happy about it until we reached a few different problems. The first problem I ran into was I completely underestimated the performance of the storage. So I went out and bought this cheapy storage array that had a dozen 7200 RPM disks in it. And, foolishly, I booted up a whole bunch of virtual machines all at once and thought, hey, this thing's performing really well. I hand it off to the users, and they hammer it so much with I/O that it actually crashed the operating system that was running the storage array. So we ran into a situation where immediately I realized that I/O was a big thing about Lab Manager. And the reason for that is that when the virtual machines are created by Lab Manager, they're linked clones, also known as delta disks. And those delta disks can occupy a much smaller space than your traditional virtual machines. Take that same storage array and a 50 gig virtual disk, you can only get maybe 20 or 30 of those virtual machines in there until you run out of space. Not so with Lab Manager. Each time you create a virtual machine in Lab Manager, it's only taking up about 32 megabytes of space initially, and it only writes to disk when it's necessary to write to disk. So you can get a lot more virtual machine density. There are ways around this, and there's proven ways of dealing with this problem that I'll talk about later on, but I wanted to bring that up. The other thing that can be a bottleneck is the shared storage processor itself, and I will talk to more detail on that when I talk about storage array configuration. And most importantly, keep in mind that if you are using VMFS, not NFS, but VMFS, there is an 8-host limit per tree, and that means that you can only have 8 ESX hosts having an open handle on a given virtual machine disk file at any given time. What will happen with Lab Manager is if you start out with, let's say, 8 hosts that all have handles open on maybe 1 or 2 base templates, you'll have a nice looking tree out here. All the hosts will have VMs deployed on them, but they all root back to the same templates. When you try to open that 9th one, it gets an access denied, and Lab Manager tells the user that they have to consolidate the disk. The reason for this is that when you get past the 8-host limit, you see a substantial performance degradation. The technical limit is 13 handles open, but there's a huge performance penalty for each one that's open past 8 handles. So that is a technical limit that we put in, and it's something where you can limit the size of your clusters using DRS. And just make sure that you limit to either data stores, 8 hosts per data store, or set up your DRS cluster so that they don't exceed that limitation. When you're scaling, you can have up to 2,000 concurrently registered virtual machines, not stored but registered. VC can only handle a certain number of actions at any given time. This is important to keep in mind because it's not really Lab Manager that's the bottleneck here. It's Virtual Center. Now that we've released 4.1, there will be a substantial increase in performance, and one of the things that can happen at the extreme top end of Lab Manager installations is the ESX hosts and the Lab Manager instance are fine, but the Virtual Center starts getting backed up with queues of commands that are coming at it, especially if you're using automation. Automation through the SOAP API can cause there to be a huge flood of requests that hit Virtual Center. So if you're seeing backlogging, if you're seeing slowdowns on the Virtual Center side of things, I highly recommend getting up to the latest revision because that changeover that we made for 4.1 to 64-bit has a substantial performance impact on the amount of commands that can be sent at any given time. The other thing that you can do here is you can cross-connect your data stores. So it's okay if you have data stores in multiple locations. Again, all you have to do is limit the number of hosts that can actually contact those particular data stores. Another good idea is to distribute your base disks amongst the different data stores. If you have multiple data stores and you have very popular templates, it's a good idea to limit your growth by evenly distributing those virtual machines, because you can run into situations where if you have a very popular configuration living on one LUN, you end up having a whole lot of users hammering that one particular LUN, and the rest of the LUNs aren't getting worked very much. So it's a good idea to think about where you're placing your VMs. And again, this goes back to needing to work with the users and make sure that you understand that the use cases your users have are matching up with your expectations. I can't stress this enough. It's some big mistake that I made when I was working in this environment. Need to know what the users plan to do with the virtual machines. If they want to have a set of templates where they're going to dump 100 gigs worth of RPM packages onto their machines every time they do that, should work with them and tell them, no, that's probably not a good idea. Let's install the packages first, capture it to the library, and then you can give that to your friends, or we can make those templates. Keep them abreast of what happens in Lab Manager, because I guarantee you give them a very long rope, but they will hang themselves with it if you give them enough time to do so. And this is mostly redundant, where it talks about the scaling, the 32 host limit per shared data store. We all know that. That's the standard virtual center stuff. Unlimited hosts and users. And this is something where the limitations that exist in Lab Manager will increase with Virtual Center. So Virtual Center is the bottleneck here. Lab Manager itself doesn't run into performance problems on that end. So I'm going to talk a little bit about managing networking here in Lab Manager. We all know about network fencing. Network fencing is a nice little feature that goes in and allows you to separate out virtual machines on the network. You have a duplicate of a configuration. You can't deploy two machines with the same MACs and IPs on the network at the same time, so we allow you to separate those out by using network fencing. Just creates a real simple one-to-one per NIC NAT routing between the virtual machines. This is nice, but it has some limitations and drawbacks, and there's some stuff I'm going to talk about that isn't on the slides here in a minute. The first thing I want to address, though, is dealing with Lab Manager and domains. First thing we recommend, if you can, put the domain controller in the fence. You can deploy as many fence copies if you want. It's okay to do that. You can have a domain controller living in a library. If you really need to update the objects, you can spawn it up, have the users clone it out. It's a real easy process to get that stuff updated if you need to get updated Active Directory information or LDAP information into your configurations. But keep in mind that you can only do that once, where you can authenticate over a fence once, and a lot of things will not work. In fact, most of the things that are in the system will not work, and the multiple copies of the virtual machines won't work at all. The objects will get tombstone in Active Directory, and it'll cause problems in other LDAP installations. The second option, of course, is using a central domain controller, but that kind of defeats a lot of the purpose of having it in the first place. The one thing that I'd like to point out about Lab Manager 4 is that Lab Manager 4 introduces the concept of having virtual networks and physical networks. So Lab Manager treats the virtual networks that the virtual machines live on as configuration-specific virtual networks. So each time you spawn up a virtual network that a Lab Manager config runs on, that virtual switch is private to that configuration. So if you have a library check-in with 3 different virtual networks and you spawn 100 copies, those don't interact. They're all on their own private networks. One of the other features that's new is that you can connect the virtual networks to the physical network. So you can have a kind of a network bridge that exists, and you can pick network by network which one you want connected to the physical network. This is extremely powerful because it allows you to have virtual networks that encompass large amounts of IP addresses, and they only have to live on these virtual networks that don't consume any real IP addresses. The only real IP address consumption you have to have is for any of the virtual machines that need to be able to talk to the outside network. And the way this would look is you can have, for example, you could have a configuration of 10 machines. Each of them have 3 networks that are shared between them. And then a 4th network can connect to all of those, and you can map one of the adapters to the physical network, access that virtual machine from the physical network, and we commonly refer to this as the jump host in our environment, where we'll have a Windows-based virtual machine we can RDP into, and then because 1 foot in, 1 foot out on that Windows virtual machine, I can go into that Windows machine and then talk to the rest of that virtual network that comprises that system, but it's all private and internal to that configuration. So that's a new feature that we have in Lab Manager 4. It's not well explained, but the way you implement it is to use the network templates feature and attach the virtual machines to the different network templates. And those will be virtual networks unless you specify that they connect to physical networks. And that can be an extremely powerful feature. And it's something that we use during the labs, that you'll see all of those different networks that the lab machines are using are all virtual networks, and you're just going into an RDP session on an individualized Windows host. Simple idea, but it allows you to do a lot more than you could in previous versions. Lab Manager with external resources like databases. You can definitely access the resources from Fence virtual machines, but whether it works or not is going to be dependent entirely on the target application. It gives you the option of deciding whether the virtual machines be inside or outside the Fence. If you can create virtual machine groups that communicate with the database over a proxy, maybe with the jump host virtual machine involved, you can do something like that. I generally recommend putting database resources, if at all possible, even if you're having to create an extra virtual machine for them to live on, have them be part of the configuration. It will be much easier on the users. And the only time that I've ever really seen people use this with external database resources and when they're essentially forced to do so, and a lot of custom work has to go into making that happen. I don't recommend running databases external to Lab Manager, but you can do it if you really need to. Saving IP addresses, I just went over the whole virtual network thing. That's a great way to save IP addresses. The other thing that's worth keeping in mind is that when you use network fencing, the virtual routers will take up 2 IP addresses. The internal IP addresses will always be reserved to that configuration until it's deleted. And then the external resources, or the external IP addresses, I should say, will be mapped to each one of the adapters that's a member of that fence. So if you have a network fence for a configuration that has 3 different physical networks mapped to it, and all of those are external facing, it's going to map an external IP address to every single one of those virtual machines. So you can take a 20-machine virtual machine with a few different networks and use up an entire Class C subnet in just a few configuration launches by doing that. So you can minimize your IP address usage by using the virtual networks. Connecting virtual to physical, as I mentioned earlier, is a good one. Also DHCP for unfenced virtual machines. And another good one is running DHCP for the internal virtual machines. If you don't feel like messing with any of the IP addresses, or it doesn't matter, then run a DHCP server internal on that virtual network. The static IP pool is specifically used for fenced virtual machines, but only when they're deployed. The IP addresses are reused when they're undeployed. They will get new IP addresses when you redeploy them. Now, this is more for the folks in the room who are running Lab Manager 2.5 or running 3.0. There are some limitations that exist in Lab Manager without the distributed virtual switch. The limitations specifically are that the virtual machines can't take advantage of HA or DRS if they're a member of a fence. And what this means in a practical sense is that the fence network has to talk to, the virtual machines in a fence network have to talk to each other over a virtual switch. In previous times, that meant that all of the virtual machines that were a member of a fenced configuration had to go onto one host because that vSwitch was local to those virtual machines. Now, all of those virtual machines being local on that ESX host can cause some room problems. If you've got 10 slots and you use up 6 machine configurations, you've got 4 slots that you're wasting. So what we did in the 4th version was allow you to use the distributed virtual switch, which makes the virtual switch distributed amongst the ESX hosts and local to all of the ESX hosts. And we implement this using the DVS and a service VM, which allows us to use MAC and MAC encapsulation to transfer the traffic that's local to the fence between the different ESX hosts. So the machines can be evenly distributed amongst different ESX hosts, and their network communications can happen local to them. Now, this has a small overhead that's associated with it. Let me skip ahead here real quick. So the overhead that it has is a small increase in MTU. I believe it's 24 bits. You don't have to go to jumbo frames to have it work. But in order for the layer 2 isolation to work, you need to increase the MTU a little bit to avoid Ethernet frame fragmentation. The service VMs that are enabled as a result of this run on each host, not on the virtual router. And the service VM can fail sometimes. You disconnect the storage or something like that. There is a repair option that will shut down and remove that virtual machine and then respawn it. Something else that's worth knowing is that the virtual machine hosts, if you put them into maintenance mode, the VM won't get off there. You actually have to go in there and disable host spanning for that specific host in Lab Manager. Then you can put it in maintenance mode, and the service virtual machine will jump off of that host and go away. So let me kick back here. This actually, I ended up covering most of the stuff in this slide, so I'm just going to skip past this part. So we're going to get into designing for availability now. Simple rule, if you can use HA and DRS, run Lab Manager as a virtual machine and protect it with that high availability. Put it on a data store that's managed by Lab Manager. We'll talk about that when I look at the backup slides. But turning these two features on can have a substantial improvement on how you use your Lab Manager environment and what the user experience is like. And the reason for this is that if you have a host failure and you're not, for example, using host spanning private networks, you can run into situations where fence VMs get HA'd and then they start up on different hosts and they can't talk to each other because they're not local to that switch anymore. If you are able to use the DVS, those virtual machines can talk to each other when an HA event happens. Same's true with DRS and vMotion. So if you have DRS enabled or if you use vMotion to move those virtual machines and you're using the distributed virtual switch, they will still be able to talk to each other. So now we're going to get into the meat of this, which is dealing with Lab Manager and dealing with storage. Storage is usually the bigger issue that I see with customers. And it's due to the fact that a lot of people don't understand how the disk chains work, the linked clone chains, or cow disks as they're referred to in this slide. We have a couple of different limitations. The first one, obviously, is the 8-host limit. The second one is we have a disk chain length that's limited to 30. That's not done for specific performance reasons. That's just done for maintenance, mostly because one of the things that you see happen is if you let your users run amok in here and they keep cloning virtual machines over and over again and you start getting chains going really long, you'll have a lot of cruft that builds up inside those virtual machine chains. And you have so much stuff that you end up getting to a point where the virtual machines that are dependent on all these different disk chains have so much data that's built up that they're actually bigger than they would be if they were just full clones. You get a lot more storage efficiency out of linked clones if they are closer to the base disk in terms of chain length than they are further away. And that's kind of a known issue with some folks, but it's something that if you look at your Lab Manager data stores and wonder, well, where did all my storage go? A lot of the time, it's due to the fact that there are huge long chains that are a result of that. So that's another thing that's helpful to teach the users in terms of best practices. The performance of linked clones is actually quite good. One of the reasons why I was tricked when I originally deployed that cheap SAN device that I had was that I deployed, I believe it was 40 virtual machines, all Windows virtual machines, and they seemed to start up just fine. They were real fast. I didn't realize that the storage array was using its cache to great benefit. It cached that virtual machine template that I was using, put it up in the storage array cache, so all those reads were coming off of the memory of that little storage array. And it made it look like the thing would outperform. So I thought it was great. I didn't realize that underneath, when you had a lot of linked clone actions, when you had clone actions, when you had just basic usage, that the I/O, random I/O of all those virtual machines was very dense and was very strong and would be able to take down that storage array. So one of the things that's important to understand about it is that there are write performance hits, and the copy process causes extra physical read and write when you're writing new blocks. The other thing that you have to be aware of is the fact that the RAID groups have a big impact on how the virtual machines perform. So SanDisk considerations are very important. Mechanical disk drive speed is the thing that's most important because linked clones can increase that I/O density. So don't worry too much about your connection methods, fiber, SAS, whatever they've got out these days. It's not going to be the bottleneck. The bottleneck is the spindle's ability to keep up with the writes. Now, I have personally used extraordinarily heavily virtual machines sitting on just regular old RAID 6, RAID DP, 15K, 300 gig drives, and it works just fine. So you can use parity groups, but if you've got slower SANs or you've got larger groups of disks that are slower, it can be helpful to configure them in a RAID 10 or a RAID 0 format with backups. And the reason I recommend that is that if you look at the kind of penalty you get for parity, especially dual parity, you're only getting about 660 gigs per terabyte out of that when you take away the parity penalty. So it's something that's worth keeping in mind if you want to look at your performance per dollar, where it might make sense to employ a striped RAID configuration rather than a parity RAID configuration on your storage array. And when you go from a parity RAID configuration to a stripe RAID configuration, you can see a humongous performance increase on the disk groups. Oops. So we'll talk about best practices, NFS versus VMFS, and I have my own personal biases here. But I think that NFS and VMFS can be useful in both situations. NFS is easier to deal with. It's easier to work with. It's not affected by the 8-host limit. You essentially create your NFS shares and pretty much away you go as long as your ESX hosts can talk to the NFS share. It does increase the CPU overhead on the ESX servers by about 20% versus Fibre Channel, and the reason for this is that the storage I/O that's controlled is being done by the processors on the ESX server rather than being done by the offload engine on the card. So that's something that's worth keeping in mind. HBAs with Fibre Channel or iSCSI can be more time-consuming to maintain. So I recommend that if you're going to go that route, while it is more performant, you might want to consider doing upgrades in large groups. If you can add capacity in large chunks rather than piecemeal, it'll be less irritating to work with. And one of the things that I remember being annoyed by was how much time I used to spend, adding LUNs, adding, zoning the different cards, remapping, rescanning, all the fun stuff that goes with adding a data store. When you have a very large configuration, and ours got up to a point where it was 30 terabytes of usable storage, and 100 hosts, that's a lot of stuff to work with. You end up spending all of your time just screwing with the storage part of things. So that's something to keep in mind when you're designing a lab manager environment. If it's going to get big, consider using NFS if you have the option. It's something where it'll be a little easier to manage. But again, block, basically VMFS, is going to be faster in that scenario. Backups. This is another fun topic. There is no good solution for backing up Lab Manager, unfortunately. The linked clone virtual machines in Lab Manager, there's just too many of them. The way their links work, none of the backup software I've seen can deal with them. I know there's some custom solutions out there that seem to handle it fairly well, but at least from my experience, we usually would individually back up virtual machines that were important, or we would snapshot the storage array and use it as a DR. The other thing that was useful about snapshotting the storage array was that if I had someone delete some virtual machines or if something got corrupted, I could mount that snapshot to a recovery host that I would use and sort of go back in time. I'd launch Lab Manager off of that data store, and this is the reason why it's good to have Lab Manager part of the same data stores. And I would go in there and just export the virtual machines and then copy them over someplace where the user could use them and either offload the software they were working with or continue working with those virtual machines until they were able to retire them. So it was a good way to sort of have an emergency last case backup. The recovery process will look like the plug was pulled on all the running virtual machines and you have to force undeploy them and all that stuff. The other thing that's worth noting is that if you use a snapshot backup strategy with a VMFS-based storage array, you have to keep in mind that the virtual machines can't be doing any linked clone actions when you're actually using them. You can't have them writing. So it's a situation where some storage arrays can handle this well and you won't have corruption, but other situations where you have to worry about that, where later storage arrays, later flare codes, or ONTAP releases, from what I've seen, are cognizant of what's happening with the virtual machine, and they'll cue that write when the snapshot is happening, rather than have it happen mid-write and have corruption happen. So just keep that in mind when you're working with your storage arrays. Know what your storage array is capable of. Test it if you can. The other thing that you can do is use the Lab Manager API just to figure out which machines are deployed, automatically suspend them, snap them, and then turn them all back on again. Something you can do in the middle of the night if you've got the time. We used to do it at 6 o'clock in the morning for our Bangalore users. The other thing that you can do is just file level backup techniques. There's no problem using backup agents inside the virtual machines. You can also use VMware Converter to just pull the virtual machine out of the ESX group. In fact, there's even some tools that I've seen that will just treat the virtual machines that are linked clones like regular ones, and they'll back them up as full clones. Another thing that you can do is use the archive feature built into Lab Manager 4, where it'll actually allow you to pick a data store, and it will make full clones of those virtual machines in a backup or archive data store. So if you've got configurations that are important, then you can use that as a backup strategy. It's also helpful to keep in mind that it's useful to have things like naming strategies, data store strategies, combination of those things. Make sure that you know which machines are which. If you're going through a software development cycle, it can be very useful to have a naming strategy that works for a specific release. So if you're working on a specific release, have the machine naming strategy follow that, and make sure that the users are aware that there's going to be a time when those virtual machines are deleted. Another thing that's very useful is make sure that you take advantage of the storage leases. The storage leases are very powerful in situations where you have users, and I know developers, I know QA testers, they'll build machines and they will forget about them. They will leave them there. I remember going through our data center when we were doing our original virtualization project, and there were machines that people hadn't logged into for 3 years. And I would ask the user, is this an important machine? They'd be like, oh yes, I absolutely need that. They never used it. Or it might be a situation where it's a machine where they need it once every 4 months for some sustaining engineering build. So that's one of the things that this lease mechanism can help out with, where people will just sort of leave things behind, they'll forget about it. Those nag emails that they get will remind them to either extend their lease or let the machines get deleted. You can even set it so that the virtual machines aren't automatically deleted and they're just expired, and then you can tell the users, well, give me a bottle of scotch or something, and maybe I'll restore your virtual machines. That was always a good one. But that's a good way of handling the storage in Lab Manager. That, and definitely training the users, using gold masters, even having the users who really understand the environment be the power users, the people who build the environments. Having all of that stuff available allows the users to understand the system better. It allows them to be better citizens in the system. When you have limited data store resources, you can use a cleanup strategy that is a little different from what I've seen most people use. And I have not seen anybody use this, but this is a good idea. The idea here is that instead of having your data stores be shared amongst everybody, you have a gold master data store where your power users build the virtual machine sets in the gold master data store, and then they clone it to a user data store where the user data store has short lease timers, and the machines essentially have short lifespans, and the users are aware of this. And this allows you to have a data store that is backed up, have gold master configurations that are full clones so they can be backed up, and you can have a good disaster recovery approach for your most important configurations. But again, this depends on how your users use the system, and it also depends on what your users are willing to do in terms of how long it takes to clone things over, how they use the virtual machines, how often they spawn virtual machines, and that sort of thing. I already talked about the naming-based cleanup strategy. The most important thing, again, user training. I used to do lunch and learns with the users. I would explain to them how things worked. I would explain linked clones. I'd say, hey guys, there's ways that you can get a lot more out of this if you just be cognizant of the rules that exist in the system. And we've had tremendous success with it before. Something else that is worth pointing out is that when you automate against Lab Manager, it's very helpful to work with your engineers and work with your test group to talk to them and say, hey guys, if I give you a system where you can automatically spawn up virtual machines in a couple of minutes, would it be helpful for us to, for example, cruise through our automated test matrix? Would it be helpful for you guys to use something like that? And most of the time, you're going to hear yes to the answer is going to be the answer to that question. A number of our customers, including my old company, have systems where they're spawning hundreds of virtual machines a day using the Lab Manager API. And they'll do full-length build chains where they'll have build systems as part of templates, they'll have test systems as part of templates, and this also integrates with things like Mercury Quick Test Pro. It works with Elastic Cloud, I think it is, Electric Commander. There are a number of different tooling sets that work with Lab Manager's APIs and allow you to automatically run through test sets and automatically spawn virtual machines. So that gave us a little extra time. We have 15 minutes left. We had quite a bit in terms of questions last time, so I'm going to open up the floor to all the folks here. Thanks for coming out and listening. Let's see, who's got questions? Questions, you over there.
So, Cloud Director doesn't seem to really replace Lab Manager. What's the future look like for Lab Manager?
So Lab Manager is going to continue to be supported. We're going to support it for at least the next couple of years, and we're going to continue developing on it. Cloud Director is a very different animal, and the way the virtual machines are handled in Cloud Director are radically different. Cloud Director is more analogous to a infrastructure as a service thing like Terramark or EC2 or something like that, whereas Lab Manager is meant for quick turn and burn, build them, use them, get rid of them kind of lab scenarios. Next question. So let me make sure I heard you correctly. The question is, if you're in a small shop, is there any advantage to using Lab Manager over using just regular virtual infrastructure? Probably the biggest advantage with using Lab Manager over virtual infrastructure is that the Lab Manager gives you a very safe, easy to use, and sanitized interface for the users, so they don't have to understand how things work in Virtual Center. And I found that, especially when you're talking to engineers, it's very difficult to train them how to use the VI client in Virtual Center. There's a lot of very steep learning curve, whereas when you log into Lab Manager, it's pretty self-explanatory. Most regularly technical users can figure it out very quickly. Any question? Yes. So you use View, and you use View to get the user local to the Lab Manager installation. So for our example, we have a data center up in Washington State. We just use View to get into the virtual machines. And once we're there, we're local to that Lab Manager installation, and that helps improve performance because it uses a better protocol than using VNC or whatever. Yes, chargeback will work with Lab Manager on a limited basis. You might want to ask Bill Call about that one. He's one of our SEs, but as I understand it, you can at least track the utilization of the VMs with chargeback. The problem with Lab Manager and chargeback is that because Lab Manager registers the virtual machines they get used and then they get unregistered from Virtual Center, chargeback, if you don't configure it right, it might not capture the fact that those virtual machines were being used at that particular point in time because it only captures at different points. You there?
Do you have a strategy for keeping the templates up to date or VMware tools and Windows updates?
So for keeping the templates up to date, the strategy that we employed was we would just use a management tool like BigFix or Altiris to manage the virtual machines. The other thing that we would do is for frequently used templates, we would just power them on, give them updates, and then shut them back off. In the template library is something we do on a weekly basis. But unfortunately, because of the way the linked clones are designed, you can't, like for example, if you've got some virtual machines that live in the system that are frequently used library configuration, it's difficult to keep them up to date because it's designed specifically so that those virtual machines are hard versioned, meaning that they are going to stay exactly as they were until they're deleted. So if you're thinking in terms of security, I generally recommend put a fence around the whole Lab Manager environment, This is another situation where view can be useful, where you can get into the environment and have it firewalled off from everything else that you don't want to worry about. And that can allow it to be more of a sandbox area where you're less concerned about those updates. But it's a good idea to have agents installed on all the virtual machines. Next question? No, linked clones cannot span data stores. You can move them using a move tool, but you can't have them span. I love your shirt, by the way. Death to SharePoint. Yes. You'll have to ask Eddie Donnell, the product manager, about that. Yeah. I don't think so. As long as we have people using Lab Manager, there will be support for it. Yeah.
Do you usually manage Windows patching? Windows patching on VMs?
Oh, Windows patching. Yeah, we just had a question about that. So our suggestion is to use either a management tool like Altiris or BigFix or Windows Update Services, or to put a larger fence around the environment, meaning keep it separated from resources that might be impacted by virtual machines that aren't fully updated. Oh, the templates. The templates themselves, you can just update them by hand. You can also use the API to kick them on, allow them to update, and then turn them back off. So that's interesting. That's the first time I've heard of that. How are you doing on your VMware tools? Fully up to date, uninstalled, reinstalled? Okay. Oh, the question was the performance of the VNC console on Windows 7 virtual machines. Interesting. Okay, that's good to know. That's actually something that we should probably file a bug against. So if you wouldn't mind sending me an email for anybody who's experiencing that, I'm sstromeyer@vmware.com. I will make sure that gets brought up with the product team and that they address that, because that shouldn't be happening. I know it doesn't have problems in, for example, Windows 2008, so that might be a driver issue there.
You mentioned a lot of different update tools, but I noticed you didn't mention VUM. So can they actually be updated with VUM as opposed to find another tool?
Yeah, as long as the virtual machines are registered and running, you can use VUM for that. Yeah, there's a zillion different tools out there. They'll all work with that. Official VMware training for the admin and the user side. There is VMware training for the admin side. That's called the VMware Lab Manager Jumpstart. You can get that as a PS offering. I do not believe that there is a user training, although I know that I have said in the past that there should be, but they don't have one right now.
Is there a specific order for upgrading my ESX environment?
If you're upgrading from 4 to 4.1, it's not a significant change, so it's not going to have an impact on the environment like the upgrade from 3.5 did to 4. Yeah. For upgrading from Virtual Center 32 to Virtual Center 64. As it regards to Lab Manager, I would have Lab Manager shut down, or at least shut down the web service while you're doing that upgrade. That's going to be true pretty much regardless. I know that if you're going to 4.1, for example, the version that you need to be up to, I believe, is 4.02 on Lab Manager. I always recommend turn off Lab Manager, upgrade Virtual Center, then upgrade Lab Manager and have it follow, and then turn the web services back on and test with it. Yeah, you basically need to export your Virtual Center database and then restore it or recreate it. No, it wouldn't affect Lab Manager. As long as it can talk to the Virtual Center instance. The other thing you can do if you want to is just undeploy the VMs, remove that virtual center instance and then re-add virtual center after you completely replace it. So that's the other option. Right. Yeah, because you can detach from one virtual center instance and attach to another one. Question?
You said before that everybody invested the use of virtual center. Would you recommend, for example, like having a virtual center for production and then virtual center for lab manager, then you can instead?
So having virtual center for lab manager and a virtual center for production? It's not necessary. You can do it if you want to. Keep in mind that Lab Manager will not take advantage of linked mode. So, for example, you tie it to your dev test virtual center instance, and you link it to prod. You're not going to be able to consume resources in the prod one. It doesn't support linked mode there. But you can link them together if you want to. That won't have any impact on it. So for keeping groups separated from a storage I/O perspective, it's very helpful to have LUNs that are siloed to specific groups. I used to do it by disk tray, so I would say that I'm going to give this 3 terabyte chunk to this group, this 3 terabyte chunk to this group. That was very good because most of the time the problem isn't the storage array head, it's the disks where the I/O bottleneck happens. I've seen some low-end storage arrays get choked with SCSI requests, like the long SCSI queues can be a problem on some of the cheaper storage arrays, so that's something to be cognizant of. The slower processors that they put on the storage arrays don't perform as well. Right, yeah. So gold masters, as they pertain to the virtual machines in Lab Manager, all they are is a marker that you can place on a configuration. And you can even set a permission that allows certain users to create a gold master. But it's mostly a psychological thing. The thing that you put out is you say to your users, okay, only use gold master configurations. And then on the back end, the assumption is that you're going to have power users or people who work in like release engineering or build engineering make good configs that all of their work can be done on top of. So that's just there's nothing particularly special about them. Let's see here. One in the back. Hang on a second. I can't hear you.
Whenever we use the API in the Lab Manager, and one of the things that we run into is paid support for using that. Is there, other than the user group where we're at in Philadelphia, no one else in the area is using Lab Manager, so we can't even fall back on that resource.
Okay.
What's out there to provide support?
For support for the API, which portion of the API are you using? Are you using the public or the private portion? Okay. So VMware support will support you all the way up to the point where they'll get engineers who design the product to talk to your developers if it's necessary. But that's only going to be for the supported portion of the API. If you have an issue that you run into with the private portion of the API, and this is going to sound silly, but if it's not supported, but you will get answers from those engineers, especially a guy named Stan Benev, who hangs out on the Lab Manager forum. And if you've got something complicated that you're doing that might be unsupported, post a question there, and that will get an answer from Stan.